Hello and welcome. In this video, I'd like to show you or give you an overview and guide you through the whole process that I outlined in a blog post about how to use both R and Python, or actually any of the external services in Tableau at the same time. So you probably sometimes also run into the situation that I ran into, both with customers while we're doing workshops, but also during sessions when I explain the whole external service integration to our customers, that you can always only use one of the two external servers at a time. So you can either run R code or Python code in one workbook, or actually in one dashboard, but not two at the same time, or at least switching between them is really painful. So in this blog post, I kind of described a process which I called the external services proxy that helps you to actually run models in both external services at the same time, or at least interchangeably. In the blog post, I outlined the whole process. You can see all the code snippets and all the commands you need to set it up. But in this video, I'd like to guide you through the whole process. I should mention that this process is not completely my own idea, so I'm building heavily on what my colleague Timo Tautenhahn and one of his customers have already built or contracted, and you can read all about it on Timo's blog, tableaufans.com. The links to those articles are also in my blog post, so there's two of them. Make sure to read both of them to kind of see the growth or the how this idea came to be. But personally, I found the description maybe a bit too general, and I wanted to give you like a step-for-step outline of how to get to that process. In addition to the blog post and to the video that you're watching at the moment, obviously all the code is also on my GitHub repository. So not only can you read all about it, but you can also see and find all the files that I'm using for the whole process on there. So maybe just also in case you didn't read the blog post, just so you understand what exactly I'm talking about and what we're going to do. Currently, as you know, you can use the script functions in Tableau to connect to the external services, but when setting up this connection, you have to decide for either R or TabPy. What I kind of wanted to do was this forwarder script, or external services proxy, as I'm calling it now, which I decided to run in TabPy. So what we're doing is we're connecting this TabPy session to the Tableau session, and we're using the script functions, which in this case don't really send the code as you're normally used to and the data, but in this case we're just sending the method name that we want to imply or that we want to run. We're also sending the service identifier. So basically, do we want to run Python code or do we want to run R code? And then, just as we know, the data as lists, argument 1 to n, depending on how many you want to run. And within this forwarder script, or in this external services proxy, based on the service identifier, it will then be decided if this code or if this data is being sent to a Python session, which I decided to run in Flask, or an R session, which I decided to run in Plumber. Both of them are, well, very handy and really well developed and maintained packages in either of those two languages that help you to kind of propagate functions as API endpoints. And you basically, what the forwarder script does is sending everything as JSON objects to those API endpoints. The models then do their thing and send back the result as JSON objects as well. And our external services provider proxy will then make this a list and send it back to the Tableau script function. So Tableau doesn't even know what's happening in the background. All Tableau knows is that it's connected to some TabPy instance, and the rest is just completely opaque from the Tableau point of view. Now, what I want to do with you is set up all those things. So let's get started maybe with a fresh console. I decided to do the whole process based on an Ubuntu machine. It doesn't really matter though. You can do that on Windows as well. It should probably also work, but I just decided to do it on an Ubuntu Linux machine. So first thing we're going to do is to install R, which is actually really simple. All we need to do is make sure that the packages are up to date, and then we can actually install R. Now, as opposed to regularly when we connect an rserv session to Tableau, by the way, rserv can also be downloaded just from the website of the rforge library. But with our external services proxy, we are not using rserv as the server application providing the R session to Tableau, but we are using this package called Plumber, as I mentioned, which basically builds an API and every function that I send to it will then be available as an API endpoint at this API. So that's actually a very nice way of propagating functions within R to other web services. So that's exactly what we're going to do. And in order to get that set up, we will have to install the Plumber package. Okay, so as you can see, this takes a while with all the dependencies also being installed and built at runtime and so on. So that process maybe took a while, but now that it's done, we should probably also check if it worked. So let's just see if the Plumber package can be loaded. And yeah, we can see it works. So yeah, that's nice. Okay, so we can get out of this R session. And what we have done so far is basically we've taken care of this part down here. So we installed R, we installed Plumber into it, and we made sure that it works. So next up is this guy up here, Flask. It's going to run in Python, and since at least for this little explanatory demo video, I decided to run all three services. So R with Plumber, Python with Flask, and also another Python session with the external services provider, external services proxy running in TabPy. Since I decided to run all three of those things on the same machine, which is probably not really a wise thing to do for a production system, but for the demo it should be enough, I decided to use Anaconda to kind of run two separate Python sessions on the same machine. So in order to be able to do that, we will now have to install Anaconda first. The easiest way to do that is to just go to the Anaconda website and go up here to download, and then pick the the operating system of your choice. In this case, I'm going to do it on Linux. I am going to choose the Python 3 version, and what I'm going to use is just a 64-bit installer. So if you hover over it, you will see the link to the actual installer script down here. So what I'm going to do is I'm just going to copy that link address, and I'm then going to use curl to get to that file. I'm going to install that, or I'm going to download this one into the temp folder, just so that it doesn't annoy me any afterwards. And then I'm just going to use curl to basically download this shell script. So that should be downloaded rather quickly. And once this is done, we can then actually execute it by just running it in the bash. And so now that Anaconda is installed, we have to source it as well. And there we are. So that was nice. Next thing we're going to do is create the Conda environment for the Flask instance. So what I'm going to do is just going to use the Conda create function. I'm going to call this one Flask. And it's also always a good choice to make sure that this is using the right Python version. So in this case, we're going to use Python 3. And now that this environment has been created, we're going to activate it quickly. And within this Conda environment, we're now going to install Flask using pip. That's just the easiest way to do that. And we're done, right? So now we have both the R session with Plumber and also the Anaconda environment, or the Anaconda ecosystem, with one environment where we also installed Flask. So we're done with those two systems. Last thing we need to do is actually build the Conda environment for the TabPy session, which then also will contain our external services script. So coming back to our console here, I'm going to create another Conda environment, which will run TabPy. This will be the one that will also run the external services proxy, but since it's just a generic TabPy session, I'm just going to call it TabPy. And again, I'm going to make sure that it's built, or that it's using Python version 3. We're going to activate it. And now that we're in this TabPy environment, we're going to install TabPy itself. And I think the easiest way to do that is, again, using pip. Just the only thing you maybe need to know is that the TabPy package is not just called TabPy, but it's actually called TabPy server. So, but once you know this, I think you should be fine. Okay, so this is done. So now one last thing maybe we can do is to check if everything works. So in order to do this, we will actually have to move into the correct folder. And I want to start up TabPy just to make sure that it's running. So we have to go to that path, side packages, and then again there's a folder called TabPy server. And once we're in that folder, that's basically the basic or the root folder for the binaries for TabPy. We can just start it up using the startup script, and that should run our TabPy. But as you can see, there is a problem. So there is this admittedly not very helpful error message that tornado.web has no attribute as asynchronous. This is kind of a known bug. It's actually not a bug. It's just the thing that there's just some version incompatibilities. So what we need to do is actually install an older version of the Tornado library. So currently, and we can see that very easily if we run pip list, we can see that currently Tornado version 6.03 is installed by default. But TabPy needs an older version, so we can again just use pip to install or to downgrade our Tornado library by specifying the version number here. And just like this, we're done. And now if we are trying to start up TabPy again, we can see that it actually provides us the information that the web service is listening on port 9004. That's perfect. That's exactly what we need. But we don't really need this session now, so we can just shut it down for now. Or actually, before we shut it down, let's maybe start it up again. Sorry about that. We can check if we can actually already connect our Tableau, in this case Tableau desktop session, to this machine. So what I'm going to do is I'm just going to open up this Tableau desktop session here. And I will try to connect this one to our TabPy session. So I'm going to the Help menu, Manage External Service Connection. And in here, I'm going to make sure that the type of external service is TabPy. So make sure to select the correct one from the drop-down list. And then we're going to connect this one to the correct machine. Also, in case of TabPy, make sure to include the HTTP. This is required here, and then we're just going to connect this one to the IP of the machine where the service is running. If you install everything on the same machine, this would be your local host. And then by default, and as you can see already in the status message of the TabPy session running, the port is 9004. So make sure to specify this and then click Test Connection. And if we did everything correct, we should now see the successfully connected to external service message. So that's nice. That worked. Perfect. So we can just close this one and go back to our console window here. We can for now actually close the TabPy session again because this is all we needed to do right now. The next thing we need to do is actually implement the models. And for this, demo use case, I decided to keep the models as simple as possible so as not to overcomplicate the whole process. So what I chose to do is basically use two scripts that only receive some text and then append the text by some message. So the R model will add R says, and then whatever text you send it to, and the Python model will say Python says, and then whatever text you send it to. That's all the models we're going to build. Maybe a few words about how this code is implemented. Again, let's start with the R side of things. This is the syntax that the plumber model needs. Basically, we define some anonymous function with all the parameters that it can receive, and all the code included in this function. In this very simple case here, as I said, is just pasting the message or the text that's being sent with R says, and then we will also convert this to a list and return it to whichever function called it. The interesting part here is this syntax up here, which is basically how the plumber module or library defines this API endpoint. The name of the endpoint will be whatever we call it. So in this case, I called it R says hello. Then we also need to specify what kind of serializer, what kind of data format will be used to send data back and forth. In this case, it's JSON. And that's basically all we need. If you want to know more about the syntax here, just read the plumber documentation. It's actually very, very nice. The same is true for the Python model. So what I'm doing here is, again, just defining a function. In this case, it has to have the same name as the API endpoint that Flask will then propagate. So in this case, again, I chose a very simple but meaningful name. Python says hello. Here we specify the method that the data is being sent. In this case, it's an HTTP post. And then the code again does nothing but just appending the text we sent it to the string Python says, and then returning everything as a JSON model. The other thing that might be of interest is that we also need to import a number of libraries from the Flask library that we installed, but that's basically it. Okay, so for now, I'm just going to make my life very simple by copy pasting this whole code and going back to my console. And let me just go back to the root directory, and I'm just going to call this one mymodel.r, this file. And what I'm going to do is I'm just going to paste all of this code in here. Okay, so obviously this is where your actual machine learning models would go. I'm going to save this one as mymodel.r, and I'm going to do the same with the Python model. Just going to copy paste everything, and I'm going to call this one mymodel.py just to keep things simple. And I'm going to paste everything in here. Okay, I'm going to save this one. Perfect. Now, the last step we're missing is the actual external services proxy. And this is where things get interesting. So let's have a look at the code. As you can see, it's Python code since we're running it in the TabPy session. We do need to import the TabPy client library. This is the one that actually can talk to the TabPy client, which then is being accessed by the TabPy server. In this case, as you can see, it's the session that we're running on the local host of that machine. Obviously, if you were running it on a different machine, this is where you would specify the port at the IP address or the machine name. And if you're running it on a different port, please also make sure to change those. And then there's one function. This is the actual function that we will be calling from the script function inside of the Tableau session, which has two parameters, the actual message, which is the text that we're sending it, and this service identifier that I mentioned earlier. In my case, it can have two different formats. One is Python and one is R. And obviously, if you specify R, everything will be sent to the R session, which in my case is running on port 6313. And we're going to look at the function or the API endpoint R says hello, which, as you might remember, is exactly the name that I defined in my plumber script. And very similar, there's a script or there's a API endpoint called Python says hello on this Flask session, which is running on the same machine on localhost port 5000. And that's where we're going to redirect the code and the data in case the service identifier is set to Python. Okay, and then we're sending the data or the message, the string that is being sent as a JSON object. Okay, and then whatever comes back from that request is being transformed into JSON and is being sent back to the Tableau session that actually invoked this model. And basically, all this function does is kind of forward data back and forth from Tableau to Python or to Flask or to Plumber and R. And in order to teach or to tell TabPy that there is this new function, we will deploy it using the client deploy function. This is the name that it will be known as. This is the actual function that we're talking about. And once this is run, we will get a little message that the model has been deployed successfully. Okay, so I'm going to use the same trick again. I'm just going to copy paste this one, and this one we're going to call deploy external services proxy to TabPy. and it's a Python function or a Python file, so we use the ending .py, and just going to copy and paste this code in here just to keep things simple. Okay, we're going to save this one. Perfect. Now that we have loaded, or that we have basically written all our model files and also provided the code for the external services proxy, we can actually start firing up everything and run it and then see if it works. So I'm going to use this top right terminal session that we have up here for running our R session using Plumber. I'm going to use the bottom right one for Python using Flask, and on the left hand side I will run the external services proxy. Let's start with R again. So all I need to do is go to my root directory and actually firing up R. So here's my R session. Again, I need to load the Plumber library. And then the interesting part is we're going to create an object in this R session, which I'm just going to call R, doesn't really matter what I'm calling it. And then the main function of Plumber is this plumb function. And I'm just going to tell it where the actual code is that we just defined that contains the function that should be deployed as an API endpoint. So in my case, this is in the home directory of this machine. And as you remember, we called it my model.r. So hopefully that works. Okay, actually, if we write it correctly, it should work. There we go, perfect. And now we need to actually run this. So we deployed the function, we deployed the API endpoint, but now we need to fire up the machine or the API. And we can do this by using this run command for the R object that we just created. And this is where I specify the port. And if you remember from my services proxy file, I told it to look for the endpoint at port 6313. I'm not using the 6311, which is the default rserve port, because maybe you also want to run an rserve session on the same machine. So in that case, they won't run into conflicts. So there we go. So starting the server to listen on port 6313 and running the Swagger UI. So that's basically the information we need. And this is exactly the endpoint that I mentioned in my code file earlier. So perfect, that is running. So let's go to the main directory and then activate the Conda environment that we defined earlier, which we called Flask. And there we go. Once we're in here, we actually need to run this thing. And there's actually a kind of longish command to do this. So the Flask app that we're running, this is where we need to specify the path that we provided the Python file earlier that contains the information about what functions and what endpoints I want to define. So again, I need to reference this. Let's see if I can get the path correct this time. And this is then my model.py file that we defined earlier. We're also going to set the debug flag to 1, just because we want to see a little bit more information. And then all we need to do is basically spin up a Python session and give it the function to run Flask. Okay, so this is the command. It's a bit longish, and if you want to know more about it, just go into the Flask documentation. You can see what's going on here. You will see this message, the warning. It's a development server. You should not use it as a production environment, which is a good hint, but for our case, it should be enough. And again, here, this is basically the IP and the port that we will use in our services proxy to actually reference whatever API endpoint is looking for it or running for it. So we have the tabpy session, we have the Python session with Flask running, we have the R session with Plumber running. The last bit that's missing is our actual services, external services provider. So for this, I'm going to activate the tabpy environment that I defined earlier in Flask. And once I'm in here, again, I'm going to fire up the session, the tabpy session that we talked about earlier. So let's just see if we can get that path again, environments, and then tabpy, the library, Python version, side packages, and then in this case, it's tabpy server. Okay, so this is the directory we need to go. This is again the root directory, and the next command looks very cryptic. All it does, so earlier we fired up the tabpy session, and as you saw, it gave us this message that it's running on port 9004, so we know it's working. The only thing is by doing that, it kind of blocked the whole terminal session. Since I don't want to do that here, I'm using this command to run the startup shell script, but I also want to kind of redirect everything into a null console so that it doesn't really block our our command line here. So I'm telling it to not take any inputs and to output output to the null device, which basically means that it's not going to print anything anywhere. The only really interesting thing it does tell us here is the process ID, 31634 in this case. So if you ever want to shut it down again, this is basically the PID you would use with the kill function to kind of shut down your TabPy session again. Okay, and then all we need to do is deploy this external services proxy code that we defined earlier. So since this is in my root directory, I'm going back here and I'm just going to run a Python session with this deploy external services proxy to TabPy Python script that we had earlier. And if you remember, in the end, I said, okay, please print out a message that the model was deployed successfully. Here's our message. So now we have everything running, I guess. We got R with Plumber running. We got Python with Flask running. We got Python with TabPy with our services provider running. So this is the magic bit. This is where we can actually test it for the first time. So in the GitHub repository, you will also find this workbook file. All I did here was just loading the superstore and defining this little function here, which I called external scripts. And if we can look into the code, it's actually very simple. All we need to do, we're still using the script functions. That's the only way for Tableau to communicate with external services at the moment. But we are not providing the full code of the model that we want to run, but we tell Tableau to look for a function called external services say hello in this TabPy session running on this port that we defined earlier. And that's where we're going to send the data, which in this case is only the first argument, which is just the name of the superstore region. And then here R, this is our external services identifier. So in this case, I want to send the name of the regions to R, and I want to read back the response object. As you might remember, in our external services proxy code file, this is the object that we send back. So this is what we want to use as a response by whatever external service is being deployed in the end. Okay, so this is the code. So if we're using this now, I'm just going to build a very, very simple viz, which is my regions in here. And then I'm going to use these external scripts function here. I'm going to drag it next to it. And lo and behold, currently we said in the function that it should be directed to R. So actually central becomes R says central and so on and so forth. Maybe if we go back to our code and change R into Python, pay close attention to what happens up here in the code. If I click apply, this will now actually be sent to Python, and now Python says central. Okay, so yeah, I think this is really neat already. And obviously there's a number of things you can do now. So one thing, for example, would be to define using a parameter which service should actually be used. Okay, so currently I have to hard code which service name should be in here. Maybe I want to use a parameter for that. So let's just go in here into Tableau, create a parameter and say external service maybe. This should be a list of strings, one of them being R, the other one being Python. Those are the two options we have. And if I show this parameter control, maybe let's put it down here so we can see it a bit better. If I now want to use the selected string from this parameter, what I can't do is this one. I can't just provide this one as a parameter and then say, okay, whatever, please use the arg2 in here. This is not going to work, unfortunately. Okay, so we see error processing script. So we kind of need to be a bit more creative, which is okay. All we need to do is kind of, since you gotta understand that everything that we send to this external service here is just a string, right? It's enclosed in those quotation marks, so it's just a string. So we can easily just use some string functions to include our external services parameter into this string, right? So we just need to break up the string and include the other string, which is our external service. And the result would be a string that contains either R or Python. The only thing we need to think of is to actually enclose that string inside of the string in the single quotation marks, so that actually is the format that the function requires. So now if I do this, we can see the parameter is currently set to R and the output is actually called R. There's no error message, and if I switch my parameter to Python, we can see that now actually the script was sent to Python and Python says well, central or whatever it is. The only thing you can also see is a little bit of output here. Since we set the debug mode to 1 on the Flask session, we get a little debug message here, which is nice if you want to test your scripts. So that's actually a cool thing. Let me just set this one back to just whatever, R or Python. In this case, maybe let's set it to Python. So what I want to do next is actually create output on the console so that we know what our models are doing, okay? Because I think that's fun, and it's also a good way to show you how easy it is to modify code basically during runtime. So let's imagine your users are using the data science models at the moment, but you can still modify the code. And the good thing is, since you don't have like lots of libraries now or lots of workbooks where you have to modify the code, there's just one central point where you can modify all that code. So that's really nice. So all I'm going to do is I'm going back to my console here, actually to the R console. I'm going to stop the R session and gonna go out here. What I'm going to do is actually I'm going to edit my model.r file, and I'm going to insert a nice little well, debug message if you want, by just printing out the message. Okay, so that's nice. I'm gonna save this one. Yes, and then I'm just going to fire up the R session again, load up the plumber library. And what I then need to do is define my model again. Obviously, you can run this one as a file. I'm just going to retype this quickly. Not a big deal. And my R model is running again. And now if I'm going to rerun this one, it's going to output some text to the console. Actually, the parameter is not evaluated anymore, so I need to change it in here. Let me just make some space here. So now if I'm running this, you will see there's the output of the R model, so I can actually see what's being sent to the model. So I think there's a number of very creative things you can do with this. I hope you enjoyed this one and I hope you were able to follow along. Again, as I said, all the code is on my GitHub repository. So if you're interested in following up on that, just go to the GitHub repository. I will keep the code updated. If you have any changes, modifications, or recommendations on how to make it even better, feel free to tell me about this. Just fork the repository and send me your requests, or just start the discussion over on my blog. I'm happy to hear what you're doing with it. Maybe you can show some examples, and also, yeah, if you have anything cool, just let us know. So thanks for your time, and enjoy working with the external services proxy in Tableau.